Welcome to my dev blog. Uh, this is probably going to be a pretty rough recording. It's not going to be edited or anything like that. I'm just going to record a little bit now and then straight onto YouTube. Um, this is going to be a dev blog about uh, the game I'm making, or well, recoding, which is the Uber Catacomb Snatch, or Catacomb Snatch. Uh, I'm going to be completely recoding the game and restructuring it as well. Uh, I'm trying to get away from the God object anti-pattern. You can look that up on Wikipedia. I'll try to put the link somewhere down here. Um, I'll probably have pauses like that a lot because I'm not exactly having a script or anything like that. Um, the way I'm going to make the game work is all of the components are going to be put together as just an assembly of components. So instead of having the entity object, which is extended onto being the mob object or the player object, and then from there then extended again into, for example, the zombie object, um, or the bat object. Instead of doing it like that, I'm going to be restructuring that so that the bat object would just be a compilation of other components that make up the functionality of the bat. For example, a bat might be something like a position component, a mover component, so a component that does all the logic for something that can move around, inertia, um, its its rate of fall off for its movement. So it would go and then slow down when it stops getting movement. And various other things like it being a target, so it can be hit. Um, Having a component that is a hitbox, and that would just send messages around. Most of the communication between the objects are just going to be messages that just get sent around the game, and that way anything that cares about really any event can just listen to the message queue, and they'll get notifications of those messages, and they'll be able to process them however they want. Uh, I'm also going to be implementing the decorator uh, pattern, the decorator pattern. I'll also try to put a link to that down in the bottom, a little bit of a thing about that. And what that'll allow me to do is, for example, game states. Normally, game states are just defined somewhere, and you run code that handles changing game states and stuff like that. But what we can do is we can integrate that into the tree so it automatically changes. For example, when the tick goes through the code, it's just going to send a tick message out, and that will trigger all of the updates that you would normally have on an update call with a update this amount of time has passed, which does your game logic, updating animations, that kind of thing. And the render calls are going to be the same way. They're just going to be a render, a message that just goes out and says, hey, it's time to render. However, what I'm going to do different is instead of having everything in one thread, all the game logic is going to be in one thread, and the render pipeline is going to be in a completely different thread. And I'm going to have a middleman in between the two that's going to handle what should be rendered and where. And what that's going to do is it's just going to send state information, global information, which will be render ID, render position, and rotation and scale. And just sending those variables into it, it'll cache them all, and that way, whenever the render call can render another frame, it'll just grab whatever it has in the current render buffer. And so when the game code runs, if the game code, for example, runs for 2 cycles for some reason during the um, the render code's 1 cycle, then it'll just change the buffer twice. And when the render code goes, I'm ready for a new buffer, it'll just pull it out. Um, so a lot of the base code that's going to run all of that is working right now, theoretically. Um, it's coded. One problem with doing component-based design is you kind of have to have almost everything working and finished coding before you can test it. So I'm going to have to later uh, go and just run it all and do a big debug session, which hopefully everything will work well. But I don't know. So yesterday, when I was coding, I was working on the render pipeline, just getting something to render. I'm just trying to get a circle to render on the screen right now with the full structure. So it'll be everything, it'll be using the same pipeline that everything will be rendered with later. It's just rendering a really simple, just simple object to the screen. I hit a little bit of a snag though, something I didn't quite think all the way through. So I just need to figure out how I want to deal with it, which is when I'm doing the render pipeline, the renderable component, which is going to be in the game logic tree, which responds to the render message saying, okay, you should render this ID with this state. That code doesn't currently have any way to go and get its object. So for example, say we're making a bat. The bat's going to have position, team, it's going to have target, and they're all going to be components. They're basically just objects in an array. But because I'm using the decorator style, that I need some way to be able to get reliably to that entity object. And I don't want to do anything where it's looking specifically for an entity object. I want it to be able to really just work on the fly with whatever's there. So what I'm thinking I'm going to do, and I'll let you know later if this works, I'm planning on having it know about what's above and below it. So the decorator will know if the command came up from the bottom or down from the top to get a component. And that way it can just pass them through to the one above and below it. That should hopefully work. If it doesn't, oh well. And this is running a little bit longer than I thought it was going to. One other thing, the decorator style, I think I forgot to tell you why it's so good for state variables. With the state changing and things, all you really need to do is throw a decorator on that's a filter. So it'll filter by state. So when that tick command comes down the tree, it hits the decorator, and the decorator says, oh, well, what's the state right now? Is it a menu state or is it a gameplay state? And say, if, for example, this decorator is a menu decorator. So the object should only show during rendering, right? So it should only pass through there if it's rendering the menus. It'll go and it'll hit that, and the decorator will get the message, the tick message, and it will say, what's the state? And if the game says the state's menu, then it'll pass the message down to its components, and they can all process it however they would normally. However, if the state is gameplay, and so this menu shouldn't be rendered. The state's gameplay, then it's going to go and it's going to say, oh, but the state's gameplay. And so what it'll do is it'll just block that message from going any further, and it won't deliver the message below. So if the objects below never get a tick message or a render message, then they won't have any way of progressing further than that. And so using those filters, it's pretty simple to change the state, or to do a state-aware gameplay mechanic. And if I need to, for example, have the object know about, um, for example, the position of one of the enemies or the damage state of a player, then I can let those messages through. So I can have a filter that blocks all except a certain type of message, or vice versa. So I could have a decorator that only accepts um, player updates, or I could have a decorator that only blocks render updates, or only blocks tick updates, or both. Um, okay, so I hope this was interesting, and please leave comments in the bottom. It really helps to make it something that I keep doing, because why should I talk to empty space? Like, subscribe, have fun, all that jazz.